Welcome back. Today we are starting a new topic that is under a broad topic called sequence and series. Under sequence and series, we have two topics. One called arithmetic progression AP and the other is called geometric progression called GP. Arithmetic progression is also called linear sequence. While geometric progression is also called exponential sequence. Okay, so if I have numbers like, let's say, 3, 5, 7, 9, the first number that appears in the sequence is called the first term. The second number that appears in the sequence is called the second term. The third number that appears in the sequence is called the third term. The fourth number is the fourth term. So if we look at these terms, there is a constant difference between the numbers. So between the second term and the first term, there is a difference of 2. Between the third term and the second term, there is a difference of 2. And between the fourth term and the third term, there is also a difference of 2. That difference is called the common difference. It's denoted by the letter D. Common difference. And the first number that appears in the sequence is called the first term, T1, or simply A. Okay? And what you have to understand is this kind of sequence where there is a constant value that is added or subtracted is called arithmetic progression. Okay? But if we have to give example of a geometric progression, let's say we have the number 3, then 6, then 12, then 24. The first number is the first term, the second number is the second term, the third number is the third term, the fourth number is the fourth term. What do we realize here is that the successive numbers are obtained by a multiple. Okay, so here it is a multiple of 2. Okay, a factor of 2. So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. So you realize that you are not going linearly, but the numbers are increasing exponentially. So that is called geometric progression. And here, the constant value by which the numbers differ from each other is known as the common ratio, is denoted by the letter R. That is called the common ratio. Okay, so under arithmetic progression, we have a common difference, but under geometric progression, we have a common ratio. So under geometric progression, there is multiplication or division. Okay, so we will discuss that later in our successive videos. But the focus of my discussion today will be on arithmetic progression or linear sequence. So let's say we have a sequence that is given by the numbers 16, 24, 32, 40, 48, and so on. So the first number that appears in this sequence is the first term. The second number is called the second term. The third number is the third term. The fourth number is the fourth term. The fifth number is the fifth term. Well, a sequence that goes like this is an arithmetic progression because the numbers are not increasing or decreasing exponentially. So there is a common difference if you look at it. So there is a difference of positive 8. Okay? So between the second term and the first term, there is a difference of 8. Between the third term and the second term, there is also a difference of 8. Between the fourth term and the third term, there is a difference of 8. Between the fifth term and the fourth term, there is a difference of 8. So if this sequence has to continue, well, we can predict the sixth term, right? What will be the sixth term? It will be 56 because we add 8 to 48. So that's the sixth term. What about the seventh term? If we add 8 to 56, we will have 64. And what about the eighth term? If we add 64 to 8, we will have 72. So the ninth term will be 80. The 10th term will be 88, and it continues like that. So there is always a difference of 8 between the two successive numbers. That difference is denoted by the letter D. Okay, we call that the common difference. The first term is also given by the letter A. Okay? So let's say we do not want to write the numbers like this because it will be more and more lengthy as we go on. So if we should write the numbers like this up to the 50th term or the 100th term, imagine how much space you would require. That will be very, very tedious. This is why we have to use formula, or we have to know how to use the formula. Let's say I want to find the 11th term, the 12th term, or the 16th term, or the 100th term of this sequence. It will be too much if I should have to arrange the numbers like this to find the 100th term of this sequence. That would be very difficult. So that is why we have formulae regarding this topic. So if we want to find the term, okay, the term which is T sub n. So T sub n is equal to A plus n minus 1 times the difference. This formula is very important. That is, if you want to find the term, let's say the 8th term, that will be T sub n. N is the term, okay, is the number of term, is equal to A, which is the first term, plus n, which is the term, minus 1 multiplied by the difference. So let's try to confirm whether the 8th term is actually 72 using this formula. It will be T sub 8. Why? Because n is 8. Okay, the number of term here is 8, is equal to what is the first term? The first number that appears in the sequence is 16. Okay, plus n is 8 minus 1 times what is the difference? The difference here is constant and is 8. So that will be 16 plus 8 minus 1 is 7, then times 8. So that will be 16 plus what is 7 times 8? 7 times 8 is 56. So 16 plus 56 is 72. So you see, using the formula, it can tell us what the term will be. So the eighth term of this sequence is 72. Okay? Again, let's say I want to find the 10th term. The 10th term, using the formula, t sub n is equal to a plus n minus 1 times the difference. The 10th term, t10, will be a, which is 16, plus the n is going to be 10 because we are finding the 10th term, minus 1 times the difference is 8. So that will be 16 plus 10 minus 1 is 9, then times 8. So that is 16 plus 9 times 8 is 72. So 16 plus 72 is 88. As you can see, that is the 10th term of this sequence. So we can be able to know the 20th term using just the formula without having to arrange the numbers up to the 20th term. That is why understanding this formula is important. So one of the important things to know is how to find the term. Okay? This formula is important. The next thing that you have to know under arithmetic progression is the sum of the terms. Okay? The sum of the first, let's say, the first 4 terms. Well, if someone gives us a sequence like this and asks us to find the sum of the first 4 terms, well, the first 4 terms are what? 16 plus 24 plus 32 plus 40. What will that give us? That will be 112. But we have a formula for that, okay? Instead of just adding it like that, we can use the formula to be able to find the sum of the terms, okay? So sum of the first, let's say, nth term, where n will be the term, is given by the formula s sub n is equal to n over 2 into a plus l. The l is the last term of the sequence. So in the question, if at all the last term is given, you can use this formula directly. But if at all the last term is not given or is not known, we have to use the formula s sub n is equal to n over 2 into 2a plus n minus 1 times the difference. I know it appears intimidating, but just take your time. It will sink. All right? Now, we want to prove that the sum of the first 4 terms, that is, if we add the first 4 terms, we're going to have 112. So let's use the formula. S sub n, where n will be equal to 4, is equal to n is still 4 all over 2 into 2 times a is 16 plus n is 4 minus 1 times the common difference is 8. So that will be s sub 4 is equal to 4 over 2 is 2 into 2 times 16 is 32 plus 4 minus 1 is 3 times 8. So that will be s sub 4 is equal to 2 into 32 plus 3 times 4 is 24. So s sub 4 is equal to 2 into 32 plus 24 is 56. So s sub 4 is equal to 2 times 56, which is 112. So you can see the sum of the first 4 terms is 112. Okay? Well, how do you know the last term is not given in the sequence? Because these 3 dots tells you that the sequence is continuous, so this is not the last term. But if the 3 dots is followed by a number, then that number is the last term. So that is how you determine the last term from a given sequence. So moving on, let's say we add the sum of the first 10 terms, okay? What will that give us in this sequence? So that is 16 plus 24 plus 32 plus 40 plus 48 plus 56 plus 64 plus 72 plus 80 plus 88. That is equal to 520, okay? So if I add up all these from the first term to the 10th term, so which are the first 10 terms of this sequence, I will have 520. Let's see, we can use the formula to get that. The formula is S sub n is equal to n over 2 into 2a plus n minus 1 times the common difference. We want to find the sum of the first 10 terms, so that will be S sub n, where n is 10. That will be n, which is 10 over 2 into 2 times a, the first term is 16, plus n, which is going to be 10 minus 1 times the difference in this sequence is 8. So that will be 10 over 2 is 5 into 2 times 16 is 32 plus 10 minus 1 is 9, then multiply that by 8. So we'll have 5 into 32 plus 9 times 8 is 72. So we're going to have 5 into 32 plus 72 is 104. So what is 5 times 104? That is going to be 520. So you see, the formula helps you to get the answer straightforward instead of writing the sequence and then adding them up. All right. Finally, I want to introduce you to what we call the nth term. Okay? In a question where you are asked to find the nth term, what you have to do is to substitute the values of a and d in the term formula, which is t sub n is equal to a plus n minus 1 times the difference, and that becomes an equation of itself. So using t sub n is equal to a plus n minus 1 times the difference, if we want to find the nth term, so that will just be tn is equal to a in this sequence is 16 plus n will still be n minus 1 times the difference is 8. So the nth term will be 16 plus n times 8 is 8n minus 1 times 8 is 8. So t sub n is equal to 16 minus 8 plus 8n. So t sub n will be 8 plus 8n. And this is called the n term. So you will substitute the values of a and d. The equation that it gives you is called the n term. And this n term actually will give you the terms. Okay? So if n is 1, just substitute 1 where you have n. You're going to have, that is going to be 8 plus 8 multiplied by 1. That will be 16. So if you substitute n as 2, that will be 8 plus 8 times 2, you will have 24. If you substitute n as 3, that will be 8 plus 8 times 3, you'll have 32. So you see, it is going to be the equation that will give you these sequences. All right? So this is an introduction to arithmetic progression. In our next video, we will be dealing with the problems. Okay? So to just summarize, we've said that the first term is also equal to a. We've said that if we want to find the term, the formula is a plus n minus 1 times the difference. We've said that if we want to find the sum of the term, s sub n is equal to n over 2 into a plus l, if at all the last term is given. But if the last term is not given, we have to use the formula n over 2 into 2a plus n minus 1 times the difference. To find the common difference, d is always the second term minus the first term, or the third term minus the second term, or the fourth term minus the third term, or the fifth term minus the fourth term, and it goes like this. What you have to understand is that the difference will be the next successive term minus the previous term, okay? Not the other way around. So you will always have to use the second term minus the first term, or the third term minus the second term, or the fourth term minus the third term, or the fifth term minus the fourth term. Okay? Thank you very much for watching this video. See you in the next lesson. And please do not forget to subscribe, like, share, and you can also comment on the video.